everyone, today I will show you the project. The name is Explore and Predict Uber and Lyft prices. And for this, I have several parts of it. Introduction of data, target, explore the data, transformation, linguistic analysis, the evolution, and the example model. And at the end of it, we have a summary. For the first part is the data. The dataset I chose was used for Uber and Lyft's user data within a certain period of time. This is a big dataset on cargo, and the name of it is Uber and Lyft dataset, Boston. The data source and data themselves can work normally, but the size of it is too large to be directly read into R, so I deleted preliminary, irrelevant variable of dataset before the project begin. And let's see the second. And for the target, my goal is to predict the price of this taxi hailing app based on different variables. The target variable is price. I also wanted to explain the correlation of many different variables with prices and how they change prices. Let's see exploit data. Of more than a dozen variables, for these three variables we explore and decide whether to keep them. First, let's see source and destination. I first exploit the source and destination of the variables. I use the plot to make the distribution diagram and box diagram. But we select at the same time the same source and destination data. It is found that the key variable price has a left normal distribution, but squared distribution is squared, which has nothing to do with source and destination, so the variable source and destination can be deleted. After that, when we log the time, location, and the name variable, we found that there are obvious differences in process for different types of name. The price of the same name changes very little. Therefore, name should be an important factor affecting the price and needs to be retained. And let's see, the darker the color of the circle on the graph, the stronger the correlation. Of the 16 variables left, I plotted the correlations using coplot function. We can see that there is a correlation area in the lower right corner of the image that is formed by 10 weather variables such as the temperature to ozone. It shows that there are a large number of the moderate of high correlation among the 10, and strongly related to our final target variable price is the car type variable, which is difference between whether the taxi is a luxury car, shared, or SUV. The price variable is also weakly correlated with the distance. Others, such as date, are moderately or weakly related to the weather. So let's see the transformation of the data. Let's see the coding line. First, I did a summary of the price, looking at the code, and found the 55095 missing values. And I then searched for missing values for the other variables and deleted them. In this case, because there aren't many missing values, we delete them. I then processed them with outliers. Let's see outliers here. Change the outliers I found to NA and delete them here. And then, as an important step, I transformed some character variables into the form of numbers here. I use the dummy code to do this. I change the variables I need to process to 1 to 12, and also conduct dummy code processing for different values in weather and cap type variable. You can see here and this 1 to 9 and 1 to 2. And both problems, some useful variables would have several peaks. Let's see. To solve this problem, I first normalize the variables and then reduce the dimensions use PCA. PCA is here. And in order to reduce the variables and change the variables that are not normally distributed. And after dimension reduction, let's see here, 16 variables become 10 new variables, and since cumulative proportion only needs to reach 19 is okay. I select the first 7 variables for subsequent modeling. For the modeling, our object is made a function to determine which price is better between Lyft and Uber, and the same circumstance. First, we divide the training set and the test set, and leave 10 rows of data for the final function. Suitability test. This is the first step, and after that, why I choose them? Since our data set is very large and the data interval is relative wide, so we need a model that can handle large data, and the model should be insensitive to edge values, and the model has to be very precise. Only when these 3 points are met can we predict the price outcomes and then convert them into normal pattern. So this is why I chose these 3 in linear regression, KNN, and decision tree. And both I show the modeling coding line. Since our data set is so large that it can take half an hour to write the code, I just show the results. We can see the coding line. You can see here, we just run half an hour, but it doesn't finish. So we can see here, the linear regression, the coding line is here. And for the second one, KNN. And the third one, decision tree. Let's see the evolution of the modeling. First, for the linear regression, first we write a function to calculate MAE. Then look at the MSE and MEE of linear regression. We use AIC results to gradually reduce variables. And then we look at the AUC. You can see here is 0.533, but the results were not good. We also use the k-fold cross-validation method to optimize the model. According to the results of the Bohr method, we finally constructed a new regression model with the optimal MAE, and the AUC reached 0.6 here, so it's better. And for the second is KNN. We find the MSE value by circling through the K value, checking to find the best K value. You can see here is a function. I used my own function to loop kn for k times is 2 to 20 to get some results, from which I selected the optimal MSE value. That's here. And the best one is k is 5. And for the third one, decision tree. First, we use the backend function to train the decision tree for many times to get the optimal solution, and then use the k-fold method in carriage to get the optimal solution. You can see here this function. But MIE hasn't really changed that much. And about the science part, example model. Let's say the coding line. From here, first of all, for the collection model, I input the basic data and the data that needs to be predicted. In function, we need and will sort all the data into the form of data and data we put into the model, including scale, train, test, and so on. And then put the data into the three models respectively, and then calculate MAE respectively. You can see here. And the MAE optimal model is used to predict the value of the new value returned to the normal form of the price. Finally, the model used and the value of the price that needs to be predicted are returned. My example model performs very well. And you can see the results of the MAE 0177. Compared with the other three models, the MAE of the example model is obviously better, which indicates that the accuracy of the example model is the highest among the four models. And for this project, I have something I want to say. After the completion of the project for 5 days, my experience is that we should use Buying to compare with other models in the future projects in order to get the most accurate prediction. Moreover, we need to consider the advantages and disadvantages of the model in many aspects when selecting the model, which can help us better understand our own data set. Of course, PC is also very useful dimension reduction method, which can make the original variables more useful. That's all. Thank you.